Section 5 is going to talk about how do we take derivatives of trig functions like sine, cosine, tangent, secant, cosecant, and cotangent. So to start off, I'm basically just going to give them all to you, but we are going to try and prove a few of them. Just realize that all of these can be proven using our limit definition of a derivative. We're not always going to prove them that way. We might take some time in class to prove at least one of them, but basically there are 6 rules here. They are a little complicated. Your job is basically to memorize them as quickly as possible so that you can put them to good use. So I'm going to try to prove in this one what the derivative of sine is. And so what I want you to do, here's a graph of sine. I want you to imagine what the tangent lines at certain points are going to be for this sine function. So I think probably some obvious ones are maybe right here. You'd have a tangent line that has a slope of 0, and here we'd have a tangent line that has a slope of 0. So if we're going to graph the derivative of sine, we're going to be graphing the sine slopes. And so right here, it would have to, the derivative would have to go through 0, so that it matches up with the slope of 0. Here it would have to go through 0. If we start at maybe right here and right here, they're going to have the same sort of tangent line slopes, and those are both going to be a slope of maybe 1. So I'd have to go through this, and I'd have to go through right there. And then the last point I want to look at is maybe right here. That will probably have a slope of -1. So we plot a -1 right there, and then if we were to connect them, we get something like this. So that blue graph is the derivative of sine, if we can kind of intuitively think about what the slopes are going to be doing, and that sure looks like a graph of cosine to me. So the derivative of sine is cosine. One way of kind of showing that. Next example, we're going to look at the graph of cosine and do the same thing basically. Look at tangent lines and what the tangent line slopes are going to be. So right here and right here both have slopes, and right here all have tangent line slopes of 0. So we're going to go through 0 there and there and there. Right here it's going to have a slope of -1, and right here it's going to have a slope of +1. And then we just connect them. Okay, now that doesn't look like anything super well known, but if you think about it, it is related to sine and cosine, and one way of getting that from a sine function is just to do a reflection over the x-axis. And so to do that, we would just put a negative symbol in front of sine. So again, kind of a simplified proof of why it might work that way, but we're going to say the derivative of cosine equals negative sine. And then if we accept that those two are fact, now we can find the derivative of tangent using the quotient rule. So I'm going to get a couple things set up here. We're trying to find the derivative of tangent, which really means we want to find the derivative of sine divided by cosine. And now we can use our quotient rule. Quotient rule says low d high. So we have cosine of x times the derivative of high, derivative of sine is also cosine x, minus high, so sine of x times, I'll do that in parentheses because the derivative of the low, cosine, is negative sine, over the low squared. And so when we square cosine, we could put it in parentheses and put the squared kind of outside the parentheses, or we can just put the little 2 right there. That means cosine squared. And then if I simplify this a little bit, really what I'm looking at is the first part is cosine squared x. The second part on the numerator is going to be a plus sine squared, all divided by cosine squared. Now in this form, Just a little algebra review. In this form, you cannot just cross them off as written like that, the two cosines. Algebraically, that does not work. There are some other things. We could split this up into two fractions, and then we could cancel some things out. But I'm going to go back to a Pythagorean identity from last year. Cosine squared plus sine squared is always going to equal 1. So really I have 1 over cosine squared. Remember that 1 over cosine is the same thing as secant. So 1 over cosine squared is really going to be secant squared. And if you look at the chart from the opening page of your notes, you'll see that that is what the derivative of tangent is. So go ahead and jot down any questions you have, and then we'll look at some other ways that we might use this in the last section of these notes.